Hey, this is Mr. Janes. In this video, I'll be showing you how to solve some more challenging Tier 2 types of problems involving area of polygons and circles. Let's start with Tier 2A, finding area indirectly. Sometimes you are not given all the lengths needed to find the area of a polygon, but you can often find those missing lengths by being a bit clever and using the Pythagorean theorem. Here's one way to problem solve through these problems. Determine which formula you will use and which lengths you will need to find the area of the figure you're looking at. If those lengths are not given, determine a way to find those lengths. Pythagorean theorem may help. And lastly, once you find the necessary lengths, find the area of the entire figure. I'll do a couple of these to show you the general process, and then you can finish the rest yourself. Let's start by taking a look at number 3. Number 3, we've got a triangle here. I know, right off the bat, that the area of a triangle is base times height divided by 2. Or 1/2 base times height, whatever you prefer. Now looking at this, do I know what the base and the height are? Well, we've got these two sides are 7 and 7, meaning that this is an isosceles triangle. And so if this part of the base is 3, this other part of the base will also be 3, meaning the entire base itself will be 6. So I can go ahead and fill in that the area of this triangle is 6 times, wait, what's the height? I don't know what the height is here. You might be tempted to say the height is 7, but that is not true. The height is always perpendicular to the base, so the height is this length right here. I'll label it h. Now we don't know what it is yet, but could we use the other measurements, such as 7 and 3, to figure out what the height is? The answer is yes. Notice that this is a right triangle, and we use Pythagorean theorem to find out what the missing side is, the missing height. So let's set Pythagorean theorem. We have the height squared plus 3 squared equals 7 squared. 3 squared is 9. 7 squared is 49. We can bring down the h squared. We can subtract 9 from both sides to obtain that h squared is 40. And then to isolate that h, we take the square root of both sides. The square and the square root are inverse operations. And rough that h is, let's use a decimal here. So h is approximately equal to 6.32 if you just pop that in your calculator and do a little bit of rounding. So, now that we know the height is actually 6.32, we can go ahead and find the area of this shape. So it's 6 times 6.32 divided by 2. And if you finish those calculations, you'll find the area of this triangle is 18.90. And it doesn't have any units, no inches, no feet, so I'm just going to write units squared because area should be in square units. Let's now turn the page over and take a look at another problem, such as number 8. In number 8, we've got ourselves a trapezoid. And the area of a trapezoid, if I remember, is going to be base 1 plus base 2 divided by 2, kind of like an average. And whatever that is, times the height. Now looking at this, what information am I given? Well, I know that one of the bases is 10, so I'll put that in here. And the other base, well, it might be tempted to say the other base is 12 right here. But in fact, that's not the entire base. 12 is part of the base from here to here, but we don't know what this is. So I'm going to call this b for now, and we'll have to figure that out later. I'll leave that blank. Divided by 2. And what about the height? Well, I know the height is 8. So 8. Remember, the height is perpendicular to the base, going straight up and down vertically in this picture, but not always. It's always perpendicular to the base, though. So how are we going to go ahead and figure out what this second base is right here? How long this is? Well, notice again, we've got a right triangle here, 10, 8, and b. And so we can use Pythagorean theorem to go ahead and solve and find what the missing part of the base is. So again, just like before, b squared plus 8 squared equals 10 squared. 10 squared is 100. 8 squared is 64. We'll bring down that b squared. We subtract 64 from both sides. And we yield that b squared equals 36. And taking it the square root of both sides leaves us with b equals 6. So now that I know that the missing part of the base is 6, I can go ahead and find that the entire base is 6 plus 12, which will be 18. I can put 18 into my equation here. 10 plus 18 divided by 2 times 8. And find that the area of this trapezoid is 112, and there's no units, no feet, no meters, so I'll just write units squared because area should be in square units. Remember, all you need to do is determine which formula you need to use. Use some Pythagorean theorem to help you out if you're missing some sides, and then find the area of the figure. Next up, area of polygons, tier 2b. This time we're looking at compound figures. So some shapes don't have a neat little formula. Some shapes you might encounter have an odd shape, like a donut or L shape. So how do we deal with those? Well, first, to find the area, we will cut the figure into familiar shapes and find the missing dimensions. For example, this shape right here, there's no area formula for that. We don't know. But perhaps we could cut this into a rectangle here and a triangle here. So find any missing dimensions that you need. For example, we know that a rectangle is base times height, which we have 5 and 4. But a triangle is going to be base times height divided by 2, and we don't quite know what this length is, or this length. So we know that this side is 5, this side is 3, so we can subtract to find that. That is 2. We know that this length is 4, and this whole base right here is 7, so we can subtract to find out that that length of that triangle is 3. We separate the shapes and find the area separately. So the area of this rectangle is 5 times 4, which is 20. The area of this triangle here is 1/2 base times height, 1/2 2 times 3, which is being 3 inches. So we go ahead and add the areas together, and we get 23 square inches. Sometimes, though, we'll need to subtract areas. For example, what if I need to find the area of the shaded region here? We've got what looks like a larger square, and then inside that a smaller square making kind of like a window or maybe a donut, a square donut shape. So how do we do that? Well, we start by finding the area of the larger square, 3 by 3, which is being 9. And we're going to subtract out the smaller square, 2 by 2, which ends up being 4. We're doing this because we are only concerned with the area of the shaded region. We don't want the area of this inside, just this kind of square donut shape. So we take the areas and subtract them. 9 square centimeters minus 4 square centimeters to get 5 square centimeters. For the next couple minutes, I'm going to show you how to do a couple others of these and maybe give you a hint on just a few more. Let's start by turning the page and going to number 5. Alright, number 5 at the bottom of the next page. Now in this shape, you've actually got some options, right, of how to break this up. Depending on who you are, different people might look at this shape differently. Now, personally, the first thing I think is I'm going to split this into a rectangle and a trapezoid. Okay, so I've got this rectangle here that is going to be what looks like 7 by 12. Okay, 7 by 12, not the 10. The 10's this whole length. And I'm going to have to add on this trapezoid, which looks to have a base of 12, a base of 8, and this height right here will have to be 3. 10 minus 7 gives me 3. And so I have to find the areas of these separately. For my rectangle, that'll just be 7 times 12. Pretty straightforward. But for my trapezoid, I have to remember that it's base 1 plus base 2 divided by 2 times the height. The rectangle ends up having an area of 84, whereas this smaller trapezoid ends up having an area of 30. And so this total area is 114, looks like centimeters squared. However, you could have also chosen to do number 5 very differently. What if you did a little bit of subtraction instead? What if you said that number 5 is one larger rectangle, right? That's 12 by 10, this whole larger rectangle right here, this whole thing. But we're going to subtract off this corner right here, this triangle. So we're going to subtract off this triangle, and it seems to be 3 by 8 minus 12, 4. So I'm going to subtract off this triangle right here with a height of 3 and a base of 4. Well, you can do that too. That's fine. 10 times 12, the area of the rectangle will be 120. The area of this will be 1/2 4 times 3, 1/2 base times height, which will yield 6. So 120 minus 6 gives me, hey, 114 centimeters squared. That's the same answer as before. So either way you look at it, you can get the area. Let's take a look at just a couple more, starting with 11 on the next page. Taking a look at 11, we have to find the shaded area, and it seems like we're going to have to start with this larger rectangle and subtract off these two smaller triangles. So let's go ahead and map that out. The larger rectangle will be 32 by 16. And I'm subtract off these triangles that have a height of 4 and a base of 6. But notice that I've got 2 of these smaller triangles. So what I'm going to do is multiply the area of one of those triangles just by 2. So the calculations. 16 times 32 for the rectangle, and 4 times 6 divided by 2 for the triangle. And remember, there are two triangles, so we multiply that by 2. So the rectangle has an area of 512, and each of the triangles has an area of 12. So if we take 512 minus 2 times 12 for those two triangles, we should get a final area of 488 feet squared. Now, there's going to be some more tricky problems I'll give you a couple hints for, so let's turn to 17 and 18 on the next page. Now, I'm not going to do 17 and 18 for you, but just a few quick hints. When you're looking at something like 17, you got to start to break this up into more than maybe just two shapes. I mean, think about this. You're going to have to break this side right here and maybe do a trapezoid, maybe another trapezoid, or, I mean, you could do something like this, where you break this up into a triangle, a trapezoid, and a rectangle. However you prefer, however you can find the measurements. Also, I'll caution you about 8. In 8, you're tempted to say that these two sides line up, but in fact they do not, right? This is 4 centimeters on this side, and this is 3 centimeters on this side. So in fact, there's a 1 centimeter overlap where this larger rectangle overlaps this smaller rectangle. So you're going to have to figure out how to deal with that. You're going to find the area of multiple shapes here. Are we going to have to subtract something in the middle? What are you going to have to do? This ends station 2B. Area of polygons, tier 2C. Now we're going to start to work backwards. Here's what I mean by that. Area of polygons, tier 2C. Now we're going to start to work backwards. Here's what I mean by that. In these problems, we're going to be given the area, so we're not going to find the area, but we're going to have some sort of missing measurement. So we're going to have to work backwards to figure that out. Now this one you might be able to do right off the bat. You're thinking, okay, this is a rectangle. The area is 25 square centimeters. One side is 5, so the other side is going to have to be 5, because 5 times 5 is 25. That's how it's going to have to be. But for this one, let's just do this out in a slightly longer way so we can get the idea of how these problems work. First, start by writing out what we know, the formula for the area of a rectangle. We know that the area is base times height. Now let's fill in any information we have. We know the total area is 25. We don't know the base. We'll leave that as the variable b, but we do know that the height is 5. Now we've got ourselves an equation with one variable, and we can solve this for b. We divide both sides by 5, and we end up with 5 equals b. So that this missing side is in fact 5 centimeters, because 5 times 5 would be 25. That's working backwards. Again, our steps were write down the equation that we know, fill in any information that we do know, and solve for the information we don't. Let's try something a little more challenging now. Hop down with me to question 7. Question 7, we've got a trapezoid, and I know the area of a trapezoid is base 1 plus base 2 divided by 2, and that times the height. Now, what information am I given here? Well, I know my total area is 48 square meters. I know that one of my bases is 4. I know the other base is 12. That'll have to be divided by 2. But I do not know what the height is. I don't know. That's the question mark. So we need to find the height. First, we can simplify a little bit, right? 4 plus 12 divided by 2 is 8. So I can rewrite this like that. 48 equals 8h. And just like the first problem, I can divide by 8 to solve for h. And I get that h equals 6. And so my missing height here is actually going to be 6 meters. Again, to recap, I wrote out the equation of the area of a trapezoid. I filled in the information I didn't know, did a little bit of simplifying, 4 plus 12 divided by 2 to get 8. And once I've simplified as much as I could, I solved for h by dividing by 8, ended up with 6. If you want to check to make sure you're right, all you need to do is take your measurements and drop them into the equation or the formula for the area of a trapezoid. Okay, times 6. And now if you multiply those, or add, divide, multiply out, drop this in your calculator, you will get that the area of that is 48 meters squared. Good, I had the right answer. Lastly, let's take a look at 9. In 9, I've got a circle. I know that the area of a circle is pi times r squared. Now in this situation, I know my area is 12.6 square miles, pi, but I do not know what my radius is. That's what I'm trying to find the radius of the circle. Well, let's see. I know that pi is 3.14, so I can divide these both by pi, and 12.6 divided by 3.14 gives me 4.01 equals r squared. And how do I deal with that r squared? Well, just take a square root. The square root of 4.01 is 2.00, and so the radius of this must be 2. And that's 2 miles there. And that's it.